Welcome back. In today's lesson, we're going to start working with equations that are a little bit more challenging than the last lesson. So we're going to be able to solve equations that use the distributive property, and we're going to be able to recognize when equations have no solutions or all real solutions. That should say all, not no. There's a typo there. So all real solutions. So first, let's remind ourselves what the distributive property is. You learned this in middle school, but let's review. So if I have a number in front of a set of parentheses, so we're going to say that A is a number and it's in front of a parentheses of two things added or subtracted together. We can say that we're going to multiply the A to the B, which gives us A times B, and we're also going to multiply that A times C. Keep the sign, and it becomes A times C. So that's the basic definition. A reminder to yourself that it is multiply, and you have to multiply both. Mistakes happen when students multiply just the first number and they forget to multiply the second. So that's why I always draw two lines to remind myself I'm multiplying by both. So in example 1, I've got 5 times x minus 3. So I'm going to distribute that 5 to the x and distribute that 5 to the negative 3. Reminder that when you multiply a whole number times a variable, you just sort of stick the two together. So I've got 5 times x becomes 5x. 5 times negative 3 is negative 15. You keep the sign with that negative 3. So 5x minus 15 is as simple as we can make this. Example B, I'm going to draw my lines again. Even though the variable's in the back, that's okay. I'm still going to multiply this like normal. So 8 times 4 is 32. 8 times negative x. If you're not sure on this one, draw in your invisible negative 1. 8 times negative 1 is negative 8. And just bring the x down with it. Now, we like our answers to have the variable in the beginning. So I'm just going to rearrange this as negative 8x plus 32. Because there is sort of an invisible plus sign in front of that 32. So that is the best way we can write our answer for this problem. And for C, same thing. Distribute 7 to 2x and 4. When we distribute 7 times something with a coefficient in front of the x, we multiply those two numbers. So 7 times 2 is 14. Bring the x down with it. 7 times 4 is 28. So 14x plus 28. Okay. So we're going to use the distributive property now to solve equations. Okay, so when I'm solving equations, I'm going to do the same way we did in the last lesson, only we're going to remember that we have to distribute first to get rid of those parentheses. So the first thing I'm going to do before I start moving things around is I'm going to draw my two lines, negative 3 times 1 and negative 3 times 4x. That gives me negative 3 minus 12x plus 5 equals negative 94. I know negative 94 is a bigger number, but like I've said in previous lessons, we need to get used to using bigger numbers. So the first thing I need to do is combine like terms on the left. I have a positive 5 and a negative 3. So I'm going to bring the negative 12x down, and 5 plus negative 3 gives me a positive 2. We're done with those two things. Bring down the negative 94. I want to get x alone, so I'm going to subtract the 2 on both sides. That cancels out my 2's. Bring down that negative 12x. Negative 94 plus negative 2 is negative 96. And my last step is to divide by that negative 12. The negative 12's cancel. And in your calculator, I would type in negative 96 divided by negative 12, or you may know this in your head mental math, and that is x equals 8. Please always put a box around your answers. That really helps me check, and it's going to help you check when you go look in the key. Okay. Letter B has something interesting going on. It's got this negative in front of it. So the way we deal with that negative in front is we're going to write a negative 1 in. That's going to help me realize that I'm multiplying everything inside by negative 1. If we don't do this, we're going to get a sign error and make a mistake. Negative 1 times negative 6 is positive 6, and negative 1 times negative 4 is positive 4x. Let's draw our line down the middle. And on the right side, we're just going to bring that 16 and that positive 2x down. Now I can go ahead and start getting my variables on the left side, my constants on the right side. So I'm going to subtract the 2x on both sides. Those cancel. Bring down your 6. 4x minus 2x is positive 2x plus 6. Bring down your 16. I'm going to go ahead and subtract the 6 on both sides. And I get 2x equals 10. Divide both sides by 2. And I get x equals 5. Okay, so trick there is to distribute that -1 in the beginning. Example C has 2 sets of parentheses. So what we need to do here is distribute twice. So the first is that 2 times 1 minus x, and then -2 times x plus 3x. I'm going to draw my line down the middle here. Bring down that 4 on the right. And on the left, I'm going to go ahead and distribute. Let me change that color. So I've got 2 times 1 is 2. 2 times -x is -2x. Then -2 times 3 is -6. -2 times 3x is -6x. Bring down that 4 on the right side. I need to combine like terms. So I've got a like term here with the -6x and a like term here with the -2x. That's going to give me a -8x. Done with these two. And then I've got to combine that -6 with the +2. So -6 and +2 is going to give me a -4. And bring down that 4 on the right. Now I need to get x alone, so I'm going to add the 4 over. -8x equals +8. Then to get the x alone, I'm going to divide both sides by -8, and I get that x equals -1, because 8 divided by -8 is -1. Okay, so that's if we distribute on the same side twice. What if we distribute on both sides? So I'm going to draw my line down the middle, and I'm going to go ahead and distribute on the left. And I'm going to distribute on the right. This should be an x, not a p. There's another typo. So -4 times x is -4x. -4 times -5 is +20. I'm going to bring down that -5x. I'm not using him yet. 2 times x is 2x, not p. 2 times 6 is +12. On the right side, I've got 2 like terms. I've got this -5x and 2x. So I'm going to just bring down the left side. And on the right side, -5 plus 2 is -3x. And then bring down that +12. I'm going to go ahead and get my x's on the same side now that my like terms are done. So I'm going to add the 3x to both sides. The ones on the right cancel. On the left, -4 plus 3 is -1x. Please feel free to write in that invisible 1 if it helps you. Bring down that +20. On the right side, bring down that 12. I'm going to go ahead and subtract the 20 now. That cancels. Bring down -1x. Don't forget the -1. And this is going to give me -8. When I divide now by... oh, I made a mistake, actually, now that I'm looking. See, we all make mistakes sometimes. So I made a mistake. I'm going to go ahead and talk about this. I made a... oh, no, I did not make a mistake. My apologies. I thought I made a mistake here, but I didn't. So apologies there. So let's keep going. This happens sometimes, right? We all make mistakes or think we made a mistake. So keeping going, I divide both sides by -1, and I get that x equals +8. Okay. So that's distributing both sides, same side, etc., how we deal with that and how we distribute. The next thing I want to talk about are different types of solutions. So normally, in a lot of the problems you've done, you get one solution. So one solution is saying that the variable equals just one value. That's what we've been doing so far. It equals just one value. So for example, 2x plus 1 Subtract the 1 on both sides. I get 2x equals 6. Divide by 2. And I get x equals 3. That is one answer, just 3, one solution. Okay? That's typically a lot of the problems we're going to be doing. But in some instances, there are equations that don't have an answer, equations that there's nothing that works to make the equation true. So that's our definition for no solution. There is no value that makes the equation true. So here's what this looks like. We're going to solve this like normal. We're going to distribute. Oh, let me change the color here. Going to distribute. So on the left side, we're going to have 5x minus 20 equals 5x minus 27. I'm going to subtract the 5x to get my variables on the same side. And you'll notice when you do this that 5 minus 5 is 0. It cancels out here. But on the left side, it also cancels out. Now, don't write 0x. That can be really confusing. Instead, just think of it as canceling out. So we're just going to bring down that negative 20, bring down that negative 27, and notice something about this equation. All my variables are gone, and I'm left with this statement that says negative 20 equals negative 27. Is that true? Do those numbers equal each other? Absolutely not. So this is not true. So that means there is no solution to this equation. There is no number that works to make this true. You can't plug anything in and get an answer that works. So you just write as your answer, no solution. We can have sort of the opposite. We can have equations that have any number will work. So that's called an all real solution. So any real number, and we've talked about real numbers before, so any real number that makes the equation true. And here's what this looks like. I'm going to go ahead and draw my line like normal. I'm going to distribute this invisible negative 1. Okay, that is a negative 1 in front, so I'm going to distribute it. Bring down that 6x. We're not dealing with him yet. Negative 1 times 1 is negative 1, and negative 1 times 5x is negative 5x. Bring down the right side. We haven't done anything with him yet. I'm going to notice that we have like terms. We have a like term here and a like term here. So that's going to give me 6x minus 5x is 1x. Oh, wrong color. 6x minus 5x is 1x. Bring down the negative 1. And we can start writing this as just x. We can erase that invisible 1, especially if it's positive. That is a better way to write it. And then I get x minus 1. I'm going to subtract that x on both sides. They cancel, both of them cancel, and I get this statement negative 1 equals negative 1. Is that true? Does negative 1 equal negative 1? Absolutely. So we can say this is true, and then we can write down that's all real solutions as our answer. Okay? So those are the things to think about for this lesson. Distributive properties, solving like we did in the previous lesson, and noticing that some of your problems in this practice will have no solution and all real solutions. Like always, please ask for help if you need it, and good luck.